right, welcome to Chapter 7, Section 2, which is called Medians and Altitudes of Triangles. This is for Integrated Math 2 or IM2. For a couple things you'll see on your screen here. You'll always see a due date here on your student side. You don't see it on my teacher preview, but you'll see it on your student screen. The second thing is the number of attempts. You always have unlimited attempts, so you can try this assignment as many times as you want. That's true for homework, tests, and quizzes. Number of questions for this particular assignment, we have 2. Rating policy is best score, so whichever attempt is the best one is one you keep. And partial credit is enabled, which means that if you answer one of 2 questions correct, you get your points for 1 question or however many you answered correctly. So down here it says once you start your homework, you must finish it before you can start anything else. That means once I click start, down here in the bottom right corner on your student screen, you don't see it on my screen, but on your student screen, you will see a submit assignment button. So you need to make sure that you click that submit assignment button for 2 big reasons. Number 1, like it said on that first screen, you can't work on anything else till you submit your homework or you finish it. That means click submit assignment. It assumes you want to leave this attempt open if you don't click that button, if you just close the screen. Remember, you have unlimited attempts, so you can come back in and try this assignment as many times as you would like. It's also going to save your place. So as long as you have a green check mark up here on the number, it will save your place and you just pick back up where you left off. If you have things clicked in here and you haven't clicked check, it's not going to save that, so be aware of that part. The other big thing that it does is it affects the gradebook. So your teacher can actually see what you've been working on. Until you click submit assignment, it's basically like your account is paused. So you definitely want to click that submit assignment button to make sure that you get credit for what you've been working on. Alright, so over here you have explanation, example, and message center. Explanation literally will give you the explanation of this problem. So the answer to it, it's not going to give you the answer and then let you type it in. So it says you're going to lose your question attempt. You'll have to come in on another attempt to try that. Example quite literally shows us, the background of what we need to do here. So there is some background. We need to know what a perpendicular bisector is, an angle bisector, a median of a triangle, and an altitude of a triangle. So with these ones, we need to know what these mean before we can move forward. So we'll talk about these in just a moment as well. And it'll walk you through each piece, how you decide what they are, and show you how to type that in. You can look at another example. So once I close this, I can look at another example if I'd like to see another one, or I can message my teacher directly from this screen. It attaches a picture so we know where to come help you. Okay. So let's go ahead and take a look at this piece, or this problem here. So we have, we're going to classify segment in each part below. Use only the information given in the figures. Do not assume measures are equal unless the markings indicate they are. What that means is don't trust the diagram. Don't actually, pull a ruler out here and start measuring things, or a protractor and start measuring the angles. Just trust the markings, or the given information here. So a perpendicular bisector, that means when we have a perpendicular bisector, we have 2 things. Number 1, it's perpendicular to the line and it's cutting it in half. So it's perpendicular and it's bisecting. When we have an angle bisector, that means we have an angle here and we have another one going through like this, and I'm dotting it just so that we can see that. So it's going this and it's cutting the angle in half. So that's an angle bisector. A median of a triangle is the segment that connects a vertex to the midpoint of the opposite side. So we actually need a triangle for this one. And we want the midpoint of the opposite side, and we're going from the vertex to the midpoint like that. So this is a median. So this is a perpendicular. I should probably put these on here. Perpendicular bisector, and this is an angle bisector. This is a median of a triangle specifically, so median of a triangle. And then we also have altitude, so that's our other piece that we can do. So an altitude of a triangle is a segment that connects from the vertex, just like this one, but it specifically connects to the opposite side and is perpendicular to that opposite side. So we want to make sure that it's, because the median doesn't have to go straight down like this, but if it does go straight down and it's perpendicular, comes from the vertex, it's perpendicular, connects to the other side, we call that an altitude. Altitude. altitude, like that. So this kind of looks perpendicular, but again, if I don't mark it, we don't assume that it is. So we're going to look for these pieces. We're just going to identify. So with this one, I can see that it's congruent and congruent, which means that this is a midpoint. It's in the middle, and it's coming from the, so this is a median. It wouldn't be an altitude because it doesn't look like 90 degrees and it's not marked that way. I don't know that it's an angle bisector. It might be, but I don't know that because it's not marked. And it's definitely not a perpendicular bisector because it's not perpendicular. This one down here, I can see the angles are marked, that they're being cut in half. So this would be an angle bisector. It looks like it's a 90 degree, but I can't depend on that because I don't know for sure. So we don't know that it's an altitude. It looks a lot like an altitude, but I can't say that if it's not given to me. And then down here we have this piece down here. I do see perpendicular. I don't know that it's bisecting though, because it's not marked that way, but it is coming from the vertex and it's perpendicular. So that fits into altitude. So again, you're just matching up. What do I see? What do the markings tell me? Don't go with what you think you know. Only go with the markings on this one. All right, so let's go to the next guy here. So now we're going to look at the centroid theorem. So this one's a little bit different. We've had a couple of these types of triangle theorems over the last couple sections. So let me grab this guy real quick. Okay, don't save. Oop, okay. Okay, so the centroid theorem, so we did in section 1, we had the incenter and the circumcenter. And those had to do with perpendicular bisectors and angle bisectors. So now we're going to look at what happens when we do medians of a triangle that meet in the center. So we have the medians of DEF, so that's just the whole triangle, are DK, and I'm going to go ahead and highlight these. So we have DK, this is a median. We also have EL, and we have FJ. So we can see that they're all crossing at this one point here in the center. And we call this the centroid. When the medians meet in the center, it's called the centroid. And specifically, this divides the triangle up kind of funky into smaller pieces. Oh, I didn't mean to do that. Let's twist that back. I don't want it to be sideways. There we go. Okay. So what it does is it kind of divides these pieces up a little differently, and I'm going to highlight them just a little different here. So we have the pink lines and we have the blue lines. So pink to blue, pink to blue, pink to blue, okay? And what it does is it divides this triangle up into almost kind of like thirds a little bit. So we have the longer pink sections, which I'll write in pink here. So pink, oh, go away, go away. So pink is going to be 2/3 of the whole line. So 2/3 of the whole line. The blue is 1/3 of the whole line. Okay, so it divides the line up, this whole piece, this centroid, divides it up into thirds, kind of an idea. Except we have 2/3 here, so I can even kind of break this up so that they're even. So I'd have 1/3, 1/3, 1/3. So here's 2/3, here's 1/3. Here's 2/3 for the pink, 1/3 for the blue. 2/3 for the pink, 1/3 for the blue. So that's the idea of a centroid. It breaks it up into these kind of thirds. So let's go ahead and put some given information in here. So we have EL. And I'm gonna go like this. EL for this whole piece, this is 24. DM, which is just from the center, the centroid over here, so I have 12. And then FM, so that's from this vertex to this centroid, we have 6, like that. And these weren't congruent marks. I don't want you to think those were. I was kind of dividing it up into the thirds there. So hopefully that's not confusing. I was not saying that these are all congruent. They are not necessarily all congruent on this one. That's not what it means. All right, so what they want us to do is go through and start finding some pieces here. So I'm going to go to my yellow and go DK. So this is the first one. They want me to find this whole length here. So remember, if this is 2/3, then I can kind of look at this and go, well, I'm going to break it up and go, well, then that means that this is 6 and this is 6. That's 1/3 and 1/3. Well, remember, this is 1/3. So that means that that is also 6. So it kind of makes it a little easier that way. If you can break it up into that third, if I have the larger piece, I'm going to break it into 2 because it's 2/3, 6 and 6. And then the 1/3 would just be the 6. So it's 6 for DK. Then I have MJ, which is this piece over here. So that would actually be the same process that I just did for MK, or DK. Oh, I'm sorry, DK. Ha ha ha. So this is 6 for MK, but the entire thing, they want the whole piece. I need to add them all together, right? So that's not going to be 6, it's going to be 18. MJ, that's the small piece here. So this one's only 6. So that means if I break it into the two pieces, it's 3 and 3 and 3. I only want the MJ there, so I only want the 3. And then ML, so they just want this piece here. Well, they gave me the entire thing. Remember, it's broken up into thirds. So 24 divided by 3 is 8. So that means that all these thirds are 8s. So if I just want the ML, then it's just 8. So it's one of those things, you have to kind of picture that. Just if you're breaking it into thirds, and then do I want 2/3, do I want 1/3, or do I want the whole thing? And you just decide how to combine those. Alrighty, so that was centroids. I will see you in section 3.